Hello folks, it is BattTube here, and today we are going to be doing a repair on an e-bike motor. This is an e-bike wheel hub motor, so in this case the motor is actually integrated into the wheel and operates the hub, or operates inside of the hub of the wheel or the rim. And in most cases, electric motors, the shaft would spin, so imagine this as the motor. In most cases, the shaft would be the thing spinning. So with the e-bike, you need the wheel spinning. So what you do, instead of having the motor stationary, you have this axle. As you can see, it is planed on two sides, so it can go into a channel which will prevent it from spinning, which will hold the axle stationary, so the actual motor will spin around the axle. And that's how you get the e-bikes to move. Pretty simple. It operates on a 3-phase AC motor. It operates off of DC, but it's a pulse width modulation, or PWM, to get the 3-phase AC. So it is AC, it's just square wave. So I have already taken out the Allen head screws. As you can see, there's weirdly drilled holes, as this is not the original case, because the motor originally did not come with the drum brakes, so I had to take the casement off of the old motor and put it onto this and make the holes work. So just gonna pull this off directly straight. The tip to this is pull it equally on both sides, as it's held in by a bushing and a bearing that is partially press fit. So you may have to pry, but make sure you are not prying from one side or you will never get it, as the tolerances are so tight that if you only pry from one side, you're only making it tighter. That's the thing about very tight tolerances. You have to pull it out very equally or it will get very stuck. So what we need to do here, as you can see, one of them I actually already pulled out, but one of these leads broke. These are the 3 Hall effect sensors for the 3 phases. So as you can see, there's green, yellow, and blue. And this is going to be the Hall effect sensors sensing the phase magnetic, the 3 phases. They're electromagnets, so when they turn on, they're going to present a signal in the Hall effect sensor, as the Hall effect sensor is just a transistor that is triggered by a magnet. So it's a Hall effect transistor. So basically, when the changing magnetic poles change based on the location, it will be able to sense that, and it will get a signal either on or off, basically, and that's going to be used to determine speed, RPM, things like that. I'm not going to go too far into detail, as there's so many tutorials on YouTube, and I'm not too familiar with the Hall effect sensors, but they're basically just magnetic switches. Alright, so basically, since only the one broke, I didn't think it made the most sense to just replace the one. As you can see, I have already done some changes in here. I did have to do some new lines, or run some new lines into the axle. So I did have to already do some rewiring on these transistors. So I figure it makes the most sense to replace all 3. If I can get this third one out. Let's get some needle nose. I went on Amazon, got a pack of 10. You can get a bunch for a lot cheaper if you went on an actual parts website, or even AliExpress or somewhere from China. You could get a pile of these for really cheap, but I needed it fairly quickly, so I just bought a pack of 10 on Amazon, which was still pennies. It was like $5, but that was still $5 basically, actually $4 more than I should have spent. So this one really does not want to come out, so we're gonna have to force it out. Looks like it just wants to break off. That's fine, that's fine. There's other ways to get you out. Let's get rid of the wires first. Okay, so that one did not want to come out. So what I'm gonna have to do, possibly break it out. There we go. So if I can zoom in, I'll show you what these little transistors look like. Close up, I'll show you a new one. One moment. Alright, so here we are a bit closer. And here are 3 new ones that I have lined up in tape just to make it easy to grab at. These are the 3 that we're going to be using. Focus. If you can see in the light there on the far right, these are 41Fs. More specifically, these ones are SS41Fs by Honeywell. These are the exact replacement for these transistors. I've already gone and checked. And in your case, you might have to go and do that. But since you've already pulled that out, you can go ahead and check on the side with the taper. So as you can see from the top, the back is flat and the front has a taper. And that is typically where your part number is located. So once you know what part number it is, probably most likely it is going to be a 41F if you're dealing with an e-bike motor, but just in case it's not, make sure you grab the correct part that you need before you move forward. Once you have those transistors though, we can go ahead and move forward. It doesn't really matter which one of these go where, they're all the same. It just matters that each one of these 3 phases gets a brand new transistor and that they are wired correctly. So it's always good to look at the data sheet for your chips. So if you get the identical ones, it's most probably going to be the identical wiring sequence that you see on there already. So in this case, if we hold it with the tapered side up, it's a positive on the far left pin, negative in the center, and the signal goes out the far right pin. Alright, so the first thing we have to do is clean up the wiring, because if you can see right here, it's fairly tight what we have to spare. There is some to spare, so I am going to see what we can pull up, if we can manage to just cut back quite a bit and get some new line, or if, depending if we don't have enough, if we're going to have to clean up what we got here and make the best use of it. So I'm going to get rid of these zip ties, and it's going to loosen up any of this slack for us. These zip ties are in here because the outer casement spins around this motor. So imagine this whole inner piece stays stationary and this outer piece spins around it. So any of the wires can rub on the outer casement that we pulled off in the beginning. So these zip ties make sure to hold it as tightly as possible to the center. That's why they are so tight. It's just the way they have to be. Keep in mind, I was the one that put these zip ties in here, these large ones. There was some in here before, obviously, but when I had to do the changes, I had to put some new ones in, and I went ahead and put some larger ones and tied it in a slightly different way. Okay, so let's see what we got here. There's another black zip tie right there, but I don't think that's necessary. As you can see, we have this it's like a fiberglass heat shielding. It also has like a rubberized coating on the outside. I don't know if it's dipped into a rubber mixture. I'm just going to cut this transistor off so we can slide those sleeves off. We're throwing out all the bad ones. Well, 2 of them are bad. The other one might not be either, but because they're so cheap, I don't want to mix those up with any good ones and possibly create problems with other devices in the future. So it does look like we have plenty of wires. As you can see, we pull it tight and stretch past. So I'm going to cut these all at an identical length. As you can see, these positive and negatives, they actually come out of a single lead and branch off for the 3 phases, as it's just supplying voltage to the 3 transistors, and the signals are going out these individual phase lines to send a signal back to the motor controller, as the type of motor controller that this motor is being used with relies on the Hall effect sensors. Otherwise it does some weird stuff, which not all 3-phase motors require a Hall effect sensors or a Hall effect sensor controllers. In fact, 3-phase motors can run very well without Hall effect sensors, but that's with controllers that aren't meant for Hall effect sensors. So I'm not really sure why the Hall effect sensor based controllers go all weird when there isn't a Hall effect sensor plugged in. That's once again not my field of study or not anything that I have studied in the past, but I guarantee you can find some information about that online or on YouTube. So I'm going to start with the power leads. Because they come out of two single leads, you can just pull them up and cut all of them at identical length. Now I'm going to start at a safe length. It may not be far enough, but I'm going to cut it just about at the shortest cable length, so they're all equally matching the shortest cable. And then we're probably going to have to cut it back. But I just want to get off this heat shrink sleeve to see what's underneath. So as you can see, these are all clean lines. This one does actually have a slight rip in it, so I'm going to keep note of that, because actually we could cut back, but it's just as easy to run the heat shrink when we do solder these lines onto the transistors. We'll just run the heat shrink just a little bit past that, no big deal. Yeah, let's do it. We're just going to cut it back. Let's just do this 100% correct this time. And remember, I'm going to be stripping some off, so I can still leave some of it. That's going to be turned into stripped wire. So, along with these ones, the black ones, I'm going to stretch them out to length with it and cut them back a bit too. Alright, so the phase lines, looks like they're basically about the same. So I'm just gonna cut them just about a wire's length above, just enough, just because we can get that bit of extra slack out of these ones. And it looks like the green one is already stripped, and it does have a piece of the old transistor soldered to it, so we will remove that, but we can already use that tip. And luckily I cut the other ones to the end of that tip, so once the other ones are soldered, they'll be basically the same length. Okay, so the next part is to go ahead and remember how we pointed out the different phases and where they were. I would have made a note earlier in the video to remind you guys to keep note of where those were, so hopefully you guys did that, because you're going to need to know it doesn't matter where you put each transistor. They're all the same, like they're all identical to each other, so any slot is good. It just matters which of these phases go to which of those Hall effect sensors. Otherwise you're going to get some weird activity using Hall effect controllers. Alright, so in my case, I just had to go back and look in the video. I really should have been able to remember, but I guess in that bit of time talking to you guys, I forgot. So I went ahead and actually marked it with a permanent marker, because it doesn't really matter where it is, it can stay there. So the next part we just have to do before we start soldering is get all of these leads prepared. So I'm going to trim back all of these other leads about the same amount as that, which is maybe 1 to 2 millimeters. Now in some cases, big strippers like this are not going to be your best bet. They may end up putting multiple splices in your line where these teeth grab, so if anything, make sure that it is on a fairly loose setting, and if you have to, you can use your finger to actually press on that wire just a little bit to hold it. Okay.
3 days later.
Okay, all good now. So let's start. Obviously we're going to start with green. Since it's on the far left, I like to go from left to right. So what I'm going to do is I'm going to take the green signal wire, and down in here I'm going to make sure that it is the first one on the farthest left, so it's not tangled in any of the other ones. And on this power lead, I'm going to take the farthest left, as well as on the black, I'm going to take the farthest left. So for now, all of these wires, I'm just gonna kind of clamp out of the way. So using a wire clamp, I'll clamp it from the other side so it's not as in the way. That'll hold all of those ones, so I have only the ones that I need. So let's get to soldering. Let me move this a bit better into frame. So you guys let me know. I'm in 3x zoom right now. I figured 10x zoom would be just a little bit too much for what we're doing right now in the ranges. So let me know if this is too far zoomed out, if you guys would like to see it a bit closer next time, or if this is perfect. Alright, so for this we're going to be using 1mm heat shrink tubing. So push that down and out of the way. Hopefully I don't heat that up too much to shrink that. I'm going to go around and do the same. As before, we have positive on the left, ground in the center, and then the green is going to go on the right pin. So I'm just going to very slightly separate these just for soldering purposes. They're probably going to get squeezed back, so that's why I'm not pulling them out too far, because the more these get bent, eventually they get brittle and break off, which is what happened to the one that we're placing, which was the whole reason we have this apart. So what I have here is some helping hands, and I do not want to destroy this transistor using the helping hands, because they're really aggressive in the amount of force that they push on it. So I'm going to do something very weird and put it in between something. I don't know, just that piece of insulation that we pulled out of here earlier, just so it doesn't put as much pressure. And since we are here, we're going to start with the far left, the far right pin, which is our signal pin. Focus back. Alright, so with some flux, this one I actually have to take a piece off. A piece of the old transistor is still stuck on that one. So with a pair of tweezers, a pair of flat needle nose, grab the tab, pull it off. That is Gandhi. Okay, so we're going to take a bit of solder and solder tin both the green lead and tin all of the transistor leads. So we want this wire to be perfectly flat, perpendicular. Oh my god, this is horrible. Focus, you fuck. So we want to hold this perfectly flat with it. Perfect. That's not too bad. Not too bad. You want to hold the wire as perfectly flat as you can. So now that the first one's done, I'm just going to get rid of the helping hands. They can go bye-bye. Alright, so the next one, have negative and positive. We will go with negative, which has to get soldered to here. Alright, so as you can kind of see, in the helping hands, the center pin, I have the negative there right in the center. Add some flux to that, and it's a lot nicer because it's held there. Well, we are going to be adding solder to this. We could have did this with the last one, but it would have been a little bit more difficult. Come back here, you bastard. There we go. Beautiful. Now, last one. We have a positive. So all I'm doing is I'm getting the wire as close as I can, and then I'm bending the exposed wires to be exactly straight with the pins, and basically so they're touching. So when I hit it with the solder and then I let go, they don't separate. Okay, so now that I have the red one ready, I'm gonna do the same one as the black. That one got a nice round blob of solder. Hopefully not too much. Hopefully the heat shrink wants to slide over still. Alright, so I just went ahead and made the correction to the red pin as well as the green pin just to make it a little bit straighter. And now we can cover those up with the heat shrink all the way up to the edge as much as we can. Okay, so with some struggle, I managed to get all of the heat shrink right up to the top. So now I'm gonna shrink it. So with this one done, I'm going to go ahead and move along to the next two. I will fast forward it and you guys can see the process just in speedy motion. As you guys seen the full process with the first one, it was a bit of a struggle to slide the 1mm heat shrink up, so I may go ahead and use a slightly a slightly larger heat shrink tubing just to cover the connections, but other than that, everything else will be the same for the next two transistors. Alright folks, so here we are, back at the wheel. Let me put that in a non-glaring state so you can see the GYB. Okay, so next, we just have to reinstall these transistors. I'm just going to get rid of some of this excess hot glue that's hanging right here, taking up space between the motor and the casing, because that could cause rubs when we add these in if these wires stick up too much. Okay, so let's start with the green here. It has to go in upside down. turn it the way that they want to be. And it's better to turn the wires than it is to turn the transistor. You want to do all of the work in the actual copper to try not to stress out the transistor leads. You are going to have to bend them once you get it into place, but you want to deal with that only once. Gotta turn it just enough to push it in that slot, wiggle it kind of back and forth, push it all the way in there. That one is good. Now we can take our fingers, push down right here, and then push down around just like that, and that's the final bend. Now we're gonna go ahead and do the same with all of these other ones. Next one is going to be yellow, which is the one that we got luckily. Now we're gonna hold the first one so it's not putting any weird stresses on it. There we go, there's that one in there. So once again, take our finger on the top there and bend that one around. Beautiful. Now, the last one is our blue one. Put a bit of a bend in that one to make it easier to slide in. A bit more of a bend. Make sure that one's pushed in all the way. Seems to be. Everything looks good. Now what we are going to do is we have to zip tie all of our leads down. But not only that, we're going to glue them. I'll show you what I mean. With just a little bit of hot glue, very, very lightly, just enough to hold them in place. Okay, folks, so I got the shitty glue gun. I just started off by holding that one in place because I just didn't like how it was moving. So what I'm gonna do is I'm gonna start over here, just in the corners. Now note this glue gun, the trigger doesn't actually work. I have to push the glue stick, but whatever. So I'm keeping this very, very flat so it does not hit the outer rim. And I'm trying not to put it anywhere like in the actual electromagnet around the outside. So I may have to actually pull some of that back. Yeah, cooled fast enough due to the fact that the motor is sinking all of the heat from the glue. So now that the start is done, I'm going to push down right here and put a small line across here. Now before I go ahead and seal this up, I will get rid of any glue strings, like any glue spider webs. Make sure there is none of that in here, because you could end up hearing it clicking. Make sure there is no wire cutoffs left inside of this casement, or you will hear it as the wheel goes round, and it could potentially get caught in something and maybe cause a short, although highly unlikely. So now what we're going to do is take a zip tie and re-zip tie this like it was before. Going to be using some ugly green zip ties. And it's a bit of a trick to get zip ties out. Basically you try and put your finger on the sharp part of the tip, and as you push, you let your finger pull. I don't know how to explain it, but yeah, just like that. So I want to make sure that it's equally zip tied underneath as well as up top, because it can rub on both sides. And I will make sure that the excess is pointed to the inside of the wheel over there. And it's completely out of the way. I shouldn't have to zip tie anything else, but I would suggest using your finger, feel underneath. Make sure there's a gap between everything and the bottom plate. And as long as there's a gap between everything, you shouldn't get any rubbing. Now these wires, they do hang down a little bit, so I am going to put a zip tie around that just in case. Alright, so now that everything is glued up, zip tied up, and in the correct spot, it's now time to seal it up and close it. Alright, so I just have to push the rim down and push it evenly, line up the holes. So I just have to put in all of the Allen head screws into the correct holes. Alright, so I went ahead and grabbed an impact driver to make this a lot easier. Now I will start some of them. Start from the top and the bottom. Now from here, I'm going to try and push it all the way. Okay, so now that I've clicked down all the way, tighten the top down. And I'll use my finger to feel the gap close. Now I will move to the left, to the right, and then do the diagonal. Now I only let them click a couple times with the impact, and I finished tightening them by hand. Now that they're all mostly tightened down, I will go around by hand and finish tightening them. Alright, so due to the fact that these are stainless screws going into cast aluminum, the aluminum is very soft and it's very easy to strip out the threads, especially considering I've had this open several times and some of these threads are already stripped because of the different drill holes. So I will tighten them down, and if I ever feel them start to get any looser while I'm tightening it, that's how you know you stop. That's how you know when to stop, because it's starting to strip out the threads. Alright, so now that the wheel is put together, the axle will actually spin now. If it spins and you guys hear anything inside of this, you know that something is rubbing. So the first thing that you want to do is get really close to it and spin it and be silent and listen for anything. So that's what I'm going to do now. Okay, so I don't think it's rubbing on anything. I did hear a bit of a weird noise, but what I will do is I will actually take it, ride it for about 5-10 minutes, take it apart, and if there is anything rubbing, you will start to see rub marks on anything that is rubbing. Alright folks, so if you guys enjoyed, please leave a like and subscribe if you guys want to see more. Hit that notification bell icon to get notified when I upload new videos. Check the description for anything related to this. Anyways guys, thanks. Hopefully this helped. Peace out.